Hi everybody, it's Honors Nope Bio 1 2013. We're looking not at the we're looking at the Sulfhydryl group today. I know that we're looking at the same thing over and over again. We looked at the carboxyl group. We know that if there's lots of hydrogen ions around, it keeps its hydrogen ion. If there's lots of OHs around, it'll give up that hydrogen ion, and if there's a very low concentration of hydrogen ions around, it'll also give that up. If there's a high hydrogen ion concentration out here, this N will take up an H, and then we know that OHs, the hydroxyl group, those are going to be sites of reactions, and methyl groups make things basically unreactive. And so let's try to figure out what the sulfhydryl group is. Now it's really important in one aspect, and I'm going to explain that in a second. So we don't need to examine it like we did the others, but let's go ahead and just take a look at one of them real quick. So this is cysteine, and it's an amino acid. You should be able to see whether this is in water, or you should be able to know. You should be able to tell pretty quickly whether this is in water, whether this is in air, whether there's lots of hydrogen ions around it, whether there's lots of hydroxyl ions around it, and so we're looking at this S. S is sulfur is yellow in CPK coloring, and it's got that H. Still not terribly exciting. Let's go ahead and put it in some water. Alright, let's get going on some water here. Bam. Alright, so let's turn that to ball and stick. Just gives us a little bit clearer of an idea. Let's turn on dispersion. Yep, thanks. That's not at all annoying. It wasn't working or anything. I'm trying to work here. Okay, so let's see if we can pause what's going on. Alright, so let's go ahead and zoom in. You can see the sulfur is interacting, but mainly, what we're getting a lot more of is that oxygen interacting, and we have no actually waters around it, so we should probably start this up again. Let's drop the temperature. Alright. Okay, now you can see a whole bunch of stuff going on. That gives us a little better of an idea of what's going on. You can see the methyl group is kind of on the outside of the whole thing, and then these guys are really interacting with the waters around them. Okay, so why is any of this important? Well, alright, so this is 2-HIU, and if you Google first glance in JMOL, you'll get this, and then type in 2-HIU. Alright, so let's cartoon off. Select all. Cartoon off. Alright. So you can see these yellow things here, and I'm going to tell you right now that these yellow things are in fact sulfurs. There's two here, so those hydrogens have popped off, and this sulfur is bonding to another sulfur. So what we saw was a cartoon, basically just strings. And sometimes rather than drawing everything out, we actually draw these strings. You're going to say, you're asking, what are these strings of? I have no idea what you're talking about, and I know. But imagine that this whole structure has to maintain this shape. Well, it would make sense that inside here there would be sulfur-sulfur bonds. So a protein that has these two sulfur bonds would actually probably be able to stay in a conformation together in the same shape better than one that had no sulfur-sulfur covalent bonds. These are covalent bonds here. And where'd my console go? Give me my console back. Console. Ugh. Alright, so cartoon off, and then let's do wireframe 50. Okay, so now you can see something that you're probably a little more familiar with. And if you look carefully, Mark. Okay, so if you look carefully, what you'll see in there is a pattern. You'll see blue, carbon. Okay, let's see if we get a better image of that. You're gonna see long chains of blue and red with a carbon in the middle of them. I'm just not seeing a good one right here. Here we go. Blue, red, carbon. Sorry, blue, carbon, red, carbon, blue, red. And so these are actually chains. This is actually one long chain of, or two long chains of amino acids. And I can show you that a little bit better here. And Adam Smith would be really mad if I did this to it, if I put this in it. So you can kind of see this green tube follows the backbone of the amino acids, and these sulfur groups are going to make sure that this thing sticks together. Now the rest of this protein, for example, let's say, let's see if I can find a good example. Alright, so this positive group here, this NH group, is probably attracted to this oxygen right here. So that's kind of why this thing is staying together. But right now, all you have to know is that if you see cysteines or sulfhydryl groups, that they're probably going to be involved in covalent bonds in these long kind of strings. So we have a long string of amino acids. You can have covalent bonds in them sometimes, and if those covalent bonds exist, they're going to be sulfurs, and that's going to be from a cysteine. And that's it.